James Spurin, who joins us today, is the Product Evangelist, or struggle saying that word, for StorageOS, with quite an extensive career spanning 20 years. I don't know if you're happy with me saying that number.
Yeah.
Covering a number of things. Me both. Covering a number of things, including obviously Kubernetes, one of the main reasons we're all here today, automation, containers, software development, storage, UNIX, the list goes on. James has actually worked for some pretty cool companies before StorageOS, one being Nomura, who are a stone's throw away from my office up on Cannon Street, literally looking across the window at him.
Used to walk past that all the time.
Yeah, brightly lit up blue and orange lights. Yeah, Dell, EMC, Hitachi, so some pretty cool companies. But outside of the industry experience, James is also an advocate for open source software, which is one of the main reasons we've all joined DevOps for Everyone in the first place. He's known for projects, contributions, technical author, and published works. Your published works have reached over 20,000 students in over 100 countries, and we were talking about this offline earlier about how you're reaching more and more students with your content. So really quite impressive there. In terms of the business, it's StorageOS, who James has joined recently. It's a software-defined cloud-native storage platform who deliver persistent storage, again, for Kubernetes. So built from the ground up, with no legacy restrictions to give enterprises working with cloud-native workloads a scalable storage platform. So no compromise on performance, availability, security, and know more about StorageOS, go to storageos.com.
Yes, that's 20 years has been a long time.
Well, I was just going to say an extensive career, but I had to throw it in there, seeing as James provided me with that.
As you were actually saying, Joe, what we're going to be covering today is Redis with persistent storage. So specifically persistent storage using Kubernetes and doing this through StorageOS. So as you just actually said about me, as you can actually see there in the picture, this was a haircut that I had outside of COVID. It's, a little bit out of control now and is needing some product support. I'm hoping that with the hairdressers coming back soon, I can get this looking a little bit more like it was in the photo. But yes, my background, I've got a mixed background which covers many different areas. So engineering, in particular, I used to focus on storage engineering. So I worked for HDS and EMC doing different bits. I worked with careers focusing on automation, DevOps, software development. I worked previously at Nomura and Goldman Sachs, really good companies. And outside of finance, again, as I mentioned, I've worked for Dell EMC and I've done work for Hitachi Data Systems. There's also a number of other ones on there. And for anyone watching, please do connect with me on LinkedIn and, see my background and anything else which might interest you. And yes, as Joe highlighted, I'm also a technical author, and outside of this, I have a course, Dive into Ansible, and some of you who's watching this may actually know me from that as well. Today's focus is Redis and the evolution of Redis. So a number of years back, there was a project which was actually looking at, and we were actually deciding at the time between this and Memcached. And Memcached was actually picked for that project. And I know from my experience when actually talking to people now about Redis is often thought about in that same way. Oh, it's just an alternative to Memcached. But since that time, Redis has evolved significantly and it has come on leaps and bounds. It is so much more than just an in-memory data structure store. And this tagline that you actually see there on the screen is taken from the Redis homepage. And I've actually called out some of the keywords on there. So it is an in-memory data structure store, but it can also be used as a database, as a cache, as a message broker. There's a whole variety of different data structures that you can actually use with this: strings, hashes, lists, sorted sets, hyperlog logs, geospatial indexes. There's lots of things. Great features built into it. So the likes of Lua scripting, transactions, and I want to call out this particular one here, on disk persistence. So Redis by default, it does actually try to have a level of persistence with the data that is actually stored in Redis. But when you kind of take a product like Redis and many other products as well, and you move it to Kubernetes, often these are running in an ephemeral way and you're not really getting the use of persistence. We're going to look at that a bit closer, and we're going to see how you can actually change the dynamics of this so you can make use of this in a nice way in Kubernetes. And on the right-hand side of the screen here, I've got 3 callouts: Redis Search, Redis JSON, and Redis Graph. Outside of what's there in the core product, there is a whole heap of modules that are also available with Redis, which really enhance the functionality of the product and give it extra things as well. So take a look at those, have a look at the Redis developer community. That Redis development community has some awesome stuff on it, which kind of showcases all of this. There's, COVID graphing, there's Hacker News clones, there's all sorts of these projects, and they are brilliant to actually see. And as soon as you look at them, I think you'll start looking at Redis in a very different way, as did I. And just to put it into perspective, this graph here, it actually shows the top technologies running on Docker, and it was done by Datadog. And you can actually see there that Redis is the second top technology according to this. And there's many other ones which are actually common there. And what we're going to actually show in this presentation, whilst we're actually showing how to take a container image and something that may by default run ephemeral, how you can actually make it so it runs with persistent storage. Even though we're talking about Redis here, you can take the examples that I'm showing, and I'm going to share all of those examples so you can reuse them as you like, but all of those examples can be reused and can be reapplied with any of these, so Postgres, Elasticsearch, Mongo, MySQL, etc. The way we're going to do this is with StorageOS. And with the challenge, the journey that typically many are actually going on with their Kubernetes adoption. So we're seeing more and more applications being built and deployed in containers. And organizations will actually they'll start using those containers. And as that actually ramps up and they have more and more containers running, then they actually need to go down this route of having a container orchestrator. And Kubernetes is the de facto container orchestrator. It has won the orchestration race. And many actually then they make that transition to Kubernetes, but they hit this third one here with the actual purple color, and that's around stateful workloads. So generally, applications store state, they have state in some kind of way, but Kubernetes cannot fully manage stateful storage out of the box. So what actually happens, you end up with organizations who they move to Kubernetes and then they say, right, we'll run this load of applications on Kubernetes, but we'll leave these ones and we'll run them in the old way that we have as well. So they don't get any of the benefits and any of that evolution which has been brought with, what is one of the most successful open source projects of all time. But through the use of StorageOS, so StorageOS is a software-defined cloud-native storage, what you're able to actually do is work in a way where Kubernetes works as you would really want it to, both for the stateless applications which are running anyway and stateful workloads. So what we're going to do is we're going to go through this And I was just going to say, just on that last note, if don't take my word on this with StorageOS. I know I'm actually here saying this at the moment, but these are a number of organizations who we have worked with or are actively working at the moment who are using StorageOS for persistent storage. So the way I'm going to actually show this today is we're actually going to go through a journey just looking at this in different ways of, using Redis as an example, how you would actually get a Redis running on Kubernetes and the journey with persistent storage, i.e., how many are running it, how many are running it at the moment, what happens if you use some of the native constructs in Kubernetes, and what happens when you then use a platform like StorageOS. I've actually done this. So for those who've seen some of my online content, I like to create my content so that it's accessible to all. So I've done this. So whether you've got an engineering background, whether you're a developer, infrastructure manager, you should be able to follow along with this. So our goal here, we've got Redis, and this is a free node Kubernetes cluster. And what we're looking to do is run container on Kubernetes. And the official Redis images are quite simply hosted on Docker Hub. And as part of this, we'll start the journey and we'll say, right, how do you actually take what is there as a de facto image on Docker Hub, and how do you then get that running in Kubernetes? We are then going to actually take that a little bit further, and we will use the volume functionality, which is in Kubernetes itself, to actually then give a backend store to this. I mentioned earlier that Redis does actually have a layer of persistence with it. It will try to actually persist data by default, which is great. And there's a lot of versatility that you can actually do with this. So we're going to look at what options Redis has, and then we're going to see how you can easily tweak Redis to take it a bit further. So if any of you do anything with Redis off the back, you can actually reuse this as well. And lastly, what we're then going to do, so this cluster that I'm using, it actually has StorageOS installed on the cluster, and we're going to show that same model and how easy it is and how much it relates to the other examples as well, just to actually run this with StorageOS volumes. The demonstration. Like I said, I'm going to actually share these at the end. I've got a GitHub repository which has all of these examples, and they're broken down and you can see them. So first of all, what we're going to do of the free nodes that we've actually got and the container that we're going to set up to actually run on this, we're going to taint our nodes. So we're going to taint nodes 2 and node 3. And what that means is Kubernetes will not be able to schedule workload to them. And the reason I'm doing this is so I can set it up so it's in a way that I can actually show you the pitfalls that you actually get with persistent storage. So we will taint node 2 and 3, and that will force any workload to go to node 1. We're then going to take that Docker Hub image, and we're going to set up Redis as a stateful set. In Kubernetes, a stateful set is it's a recommended Kubernetes object for running what will be stateful workloads. We'll check Redis is running. We'll populate some data. So I've actually taken the data from the Redis developer community. So where I said to look earlier, they've got some brilliant projects, including data sets that you can actually use for samples. We'll check it exists. Then we'll delete it. We'll let the Kubernetes controller take charge and recover that. and we'll see where we actually are with the data. So this is example 027. Okay, so this first example, I was saying that what we're going to do is taint the node. So as we go through this, just for clarification, depending on your Kubernetes knowledge, this first bit just gives a simple breakdown of what we're actually doing. And here's the actual Kubernetes commands that we're running. So in this case, we've removed this taint if it existed from this node, and we've tainted 2 and 3. And quite simply, from a Kubernetes viewpoint, it's exactly the same command. The only difference is the minus. If you've got the minus on the end, that's actually going to remove the taint. Oh, and I'm just going to do this now. I'll just show you. You can actually see there that this is a 3-node cluster. So I've untainted what would be this one, and I've tainted nodes 2 and 3. And next thing we're going to do is set up Redis. So again, if you're pretty new to Kubernetes, this might actually seem like a lot, but this is using the stateful set Kubernetes object. It's literally taken from the Kubernetes docs as it is. And the only thing that's actually changed there is the image. So we're using this Redis image, and we've opened up the port. And you can actually see there, this has been applied, and this is the output, that it's actually created this stateful set. If we check, we can actually see that we have this stateful set. It's been running for about 37 seconds. And off the back of that, it's created a pod, which is running Redis. And as expected, because of the taints, this is running on node 1. Then what we're going to do is we're going to copy the data from the Redis developer data sets that I mentioned. I've just got this as a directory here, and we're copying it into the container. So kubectl copy this directory to here. Then what we're actually doing is we're importing that data. So it's just quite simply within the container, it's passing this, and then that's piping it through the Redis CLI. So now we've added in within Redis what would be data sets for films, actors, and users. And if we actually check this, we can now see there that we've got 7,605 keys in Redis. So these will actually be in Redis memory at the moment. And as I say, Redis would actually be trying to persist this data as well. And we'll look at this a little bit closer. But for now, if we actually delete that pod, and we show what would have happened here, because we have this running as a stateful set, the stateful set would have said, I'm expecting this to actually be running. It realizes it's not, and you can tell there from the actual time that this has been recreated. So it's recreated this Redis pod. And now if we actually count the keys again, we've lost the data. So above, you can actually see here that we had 7,605 keys. Now we have an empty key space. This is a typical example ephemeral workload, which many organizations are using Kubernetes for, because moving to stateful environments is a little bit more difficult and has its challenges. And we'll see in the next bits how we can actually get past that. So if I go back to this deck, what we're going to do in these next examples is we're going to just take a little look at Redis, what Redis provides with its default persistence and how we can tweak this a little bit. We're going to tweak this through the use of what's known as an append-only file. We'll check that that's been applied, and it's quite nice because you see some of the, how Kubernetes works and how Kubernetes responds to application changes. We're also going to see what Redis is trying to do from a file system perspective with that data. So if we just go to, this is example 8 to 14. So now let's check what Redis actually has there as its persistent. So we're just passing commands here. We're using kubectl to pass it into the container, but quite simply we're saying, give me the configuration for save and give me the configuration for append only. And that's going into the Redis CLI. So these numbers, they look quite confusing, but what they actually mean, if within 3,600 seconds, Redis receives one entry, it will create a dump, a snapshot of that data. If within 300 seconds, it receives 100 entries, it would create a dump again. If within 60 seconds, it receives 10,000 entries, it will create a dump. So the more data that actually goes in, the more frequently it's actually going to take a, do a snapshot of that data and persist it. But logically, if you look at this, you can actually see that this has a flaw in itself because you're only periodically saving data. And this is, this is a good use case, even though this is actually there. This might actually work for some who don't need to have all the data, but you can actually tweak this further. And this is through this append only. So at the moment, this is set to no. And what we're going to do is tweak this so it's set to yes. And what that will mean is it will still dump data, but if there's something which is transient, it's going to add it to this append only log. So if we look, what we're doing here is we're rerunning that same configuration that you actually saw earlier. So all of this is exactly the same, but now we've actually changed this one line where these are arguments that get passed to the Redis image. So we're saying append only is yes, and if within 30 seconds there's 100 entries, do a dump. That's the only line which is different, and Kubernetes has now reconfigured that application. And off the back of that, because that application has changed, Kubernetes controller has now gone, okay, what's running at the moment doesn't match what I've got. I'm going to delete that and I'm going to recreate it. And you can see that here, that's evident because our stateful set has been running for 6 minutes at this point, and we've got a brand new container running, which 22 seconds corresponds to when I made that last change. So if we now check Redis persistence, it's configured in the way we expect it. And if we populate our data again, and we check the keys, we now have the same. We have the 7,605 keys. And what this has actually done, here, we're going to take a peek in the container, and you can actually see in the data directory, it has now, it's created the dump. So all of this in Redis is being served from memory, but it's also got this as a dump file, and it's got the append only file. So Redis is trying here, but because this data is ephemeral, when we lose this, it's not really going to provide much in the way of a benefit. So what we're going to do next is we're going to set this up with a volume. And this is as per Kubernetes, it's a standard volume. We're then going to populate this with data, and then we'll delete the pod and we'll actually see what happens. And at this point, you'll notice that the Kubernetes terminology is referring to this as persistent volumes. But I want to go through this and just show some of the fundamental flaws with it. So working on our configuration again, what we're going to do is we're going to rerun this. But this time we've got some added blocks in here. First of all, we've got this. This is a persistent volume. Again, this is an example just taken from the standard Kubernetes documentation. And we're saying create a persistent volume, and we want 1 gig. Next, underneath this, we have a persistent volume claim. and we're making a claim for 1 gig. So at the moment, there's only one volume created on this, and there's a claim for that. So essentially, this claim is then going to claim that persistent volume that we created. Then we have the same application that we had originally, but now there's some additional sections in here. We have the volumes, and this is referencing the claim. So you can see how this is cascaded. The declaration here is specifying the claim, and then the claim is linked to the volume. So we're bringing in the volume here, and we're telling it to actually mount /data. So it created the persistent volume, it created the persistent volume claim, and we've reconfigured our application. And if we check again now, what we've got our stateful set running there. Our pod is running. This has been running for 88 seconds. We've got a persistent volume, and we've got a persistent volume claim. There'll be no keys at the moment because this is newly created. Let's actually copy our data into Redis. And we count the keys. So there we are, we're back. We've actually got 7,605 keys. And this time we've actually got a back-end store for this data. Now, if we delete the pod and we actually then check what's actually happened here, we've recreated our pod. So that's there with 6 seconds. And this time, if we actually count the keys, you can actually see what's happened because we have that back-end store with the volume and persistence is configured in Redis. As this has actually started up, it's read those files and then it's brought those keys back into Redis. So they are there served from memory now. And you kind of look at that and you think, okay, well, that's great. We have persistent storage, but at the moment, this is limited to this node only in the cluster. And what I've actually seen out in the industry is rather than people actually, using this in the best way, they've tried to work around the problem. Well, if my data is only on that node, I'll make my container so it only runs on that node, or I'll put in some kind of node affinity rules which prevent it going elsewhere. You can do that, but then you really, really lose the true benefits of what you're actually getting with Kubernetes. And you can actually see this in these next examples. So what we're going to do here is we're going to change our taint around. So at the moment, this seems to be working as persistent storage whilst we're here, but we're going to change this taint so that node 1 and node 3 are tainted, and then we're going to delete that pod. And when the controller kicks in this time and it tries to reschedule it, the only one that it's going to be able to do this to is node 2. If we run the taint, so you can actually see there, we've tainted node 1, tainted node 3, and if the taint existed on node 2, we've actually removed it. And we delete that pod again. And okay, great. And as I say, the controller is going to kick in here, and you can actually see there that now this is actually running on node 2 of our cluster, StorageOS K82. But if we actually check the keys, the key space is empty because, whilst we were actually doing it, that storage that we actually saw previously only will ever exist on that one node. So this cluster that I'm using, it already has StorageOS installed, and we've got some videos and documentation on how to do that. It's practically a one-liner that you actually do, and that sets up StorageOS within your Kubernetes cluster. So what we're going to show next in this example is the equivalent of what happens if you actually use StorageOS. And StorageOS has its own container storage interface. So we actually integrate natively with Kubernetes. So you're using all of the same declaration like we actually saw, but when you actually run it, StorageOS is working in the background. So here we have the cluster with StorageOS installed, and we're just going to tweak that configuration a little bit so that it's using StorageOS for its storage class rather than the native Kubernetes one. So, oh yeah, and just whilst we're doing this as well, I'm going to taint nodes, after we've actually configured, I'm going to taint nodes 1 and 2 and show what happens then with a failover to node 3. So, okay, first of all, I'm just cleaning up and I'm removing what's there. So that's getting rid of the stateful set and the old volumes. And when I went through the example earlier, you'll recall that I created a persistent volume and I created a persistent volume claim. When we're doing this, all we're actually doing here is we're doing the persistent volume claim. And when you use StorageOS, so this bit here and telling it to use this storage class is telling it to use StorageOS. You only need to make the claim. You only need to say, I need this amount of storage. And StorageOS will actually create the volume for you. So by actually using StorageOS, your declaration and how you actually do this becomes a lot easier. We actually work with Kubernetes principles, and the functionality of your volume you actually add this by including labels. So here we've actually added a label and we've said replicas of 2. So what that actually means is you're going to have your primary data and then replica 1 and replica 2. And this is a 3-node cluster. So in this case, we will have a copy of the data on every node. So here you could lose an entire node, or you could lose 2 nodes, and you would still have access to your data. And those labels are used elsewhere. So if you wanted to add other features in within StorageOS, you can just add them there. And this bit at the bottom is exactly the same as it was before. There is no change. We have got the actual claim name. So I've used the same name as previous. So all we've had to do is put this in. And if we actually look now, you will actually see there that we've got a persistent volume. So this persistent volume it's actually got a UUID as the name, and it correlates to the persistent volume claim. So we only specified the persistent volume claim, which is created here, and it's created the persistent volume. And I really like that, we actually use the UUID there as the name. It's very easy to say that, to see that this persistent volume relates to this persistent volume claim. And this is actually running. So now let's copy and populate our data. So again, we've imported all of that and we count the keys. We've got our 7,605 keys. We're going to taint so that next time this is actually scheduled, it will go to another node. So it can't go to node 1, it can't go to node 2, it can only go to node 3. And this time, we're going to delete the pod. And just, if we give this a moment just to come back up. When so what's happening here, again, the controller is going to kick in, it's going to reschedule this, but when the volume actually comes up this time, even though it's moved to a completely different node in the cluster, when StorageOS treats persistent data, it's actually treating it as accessible from any node in the cluster. Okay, so this is running. This has been running for about 34 seconds, and you can see there that it is now on a completely independent node. And if we count the keys, you can actually see that this has actually worked as expected. So you've got highly available persistent storage working in the native way you would with Kubernetes, and it's working, from my perspective, it's working the way that I would actually expect to see it. So just on that, I showed that use case there, that demonstration, and like I actually showed all of those different ones which you saw in that chart, the Postgres, the Mongo, the MySQL, they're all ones which work in a very similar way. And if there's a file system involved, you can work it like that. So just alone as it is, StorageOS provides a tremendous benefit for Kubernetes, essentially opening up the whole window. So it's not just ephemeral workloads. You can run your databases, your message queues, anything you need. Some of these ones really to tell a good story here. So with Kubernetes, we've got this declarative self-service storage. We're not working as a separate product behind the scenes that you have to configure and do differently. We natively plug into Kubernetes. And as I showed there, you saw how it was with the, when you're using the standard types of Kubernetes, and there was one word different to actually say, hey, use StorageOS's storage class rather than the built-in Kubernetes one. This, because you are able to actually template your entire application and declare your application, it becomes highly agnostic. So you can actually take that and you could run it on a StorageOS, enabled Kubernetes cluster on-prem. You could run it on an AWS cluster. As long as StorageOS is there, that will transparently work, or any other cluster as well. We are highly performant with something we pride ourselves on is deterministic low latency. So you can actually get the platform in, you can do some tests, and what you actually get there, you have a high degree of confidence that you're going to be able to continue to achieve this. And I make a reference to this at the end. We recently, there was a paper published recently where StorageOS was actually benchmarked against three of our competitors, and in every test that was actually performed, we outperformed all of them. So please, at the end of this, take a look at that link and see the different types that were done, and the expertise from a storage perspective which is behind that. So integrated with all leading distributions and services. We're a Kubernetes platform, so you can run this on any Kubernetes platform, and this also means that it works with variations as well. So the likes of OpenShift, which are Kubernetes at core as well. Those with a distributed computer background would probably be aware of this term, disaggregated consensus. What this essentially means is we've built the product so that it can scale and continue to scale. And the way you do that is with these approaches, this kind of approach, this disaggregated consensus, we allow each volume to independently run and make decisions about itself and its health. And I've shown it here on a simple 3-node cluster, but you could just as easily run this on a 1,000-node cluster and it would work as expected. Highly availability. In that example which we went through, I showed 3 replicas, and it was as simple as a label that you put in. And in that same way as I showed the label, you could just as easily do a label for encryption of data and not only that, not only do we provide encryption at rest, we also provide end-to-end encryption. So all of the communication that actually takes place between various nodes in the cluster is encrypted as well. And this slide goes into that a little bit more. You've got the coverage there of the data in transit. And it's worth pointing out on the data at rest, we actually use the processor AES-NI instruction set. So that's there on AMD processors, it's there on Intel processors. And that allows us to actually do the encryption with a very low overhead. We essentially offload encryption to the processors. Oh, and yeah, this is a good one as well. Fencing and rapid failover. So in that example, I used a stateful set, which is the recommended type of Kubernetes object for when you're working with stateful applications. And what could actually happen if you had a failure of a node there, you might get a holdup of up to 5 minutes before something is actually done and actioned on this. And there's, if you look into this, there's good reasons behind it. It's trying to make sure, because there's certain constraints that get put in place when you're running something in a stateful set, unique name, and a consistent name that is specific to that stateful set. It likes to ensure that something is really dead before it hands over. StorageOS runs in the background, and we run across the Kubernetes cluster as a daemon set. So it's running on every node, and we have our own independent gossip protocol, which is actually going on. So what the product does is it assists Kubernetes here. So when there is a failure detected and it's in that state where it's saying, right, what do I do here? Can I schedule this to another node? We assist, we influence that behavior. And what this allows us to do is increase this by up to 500% in terms of the recovery time. So taking the 5 minutes typically to between 30 to 60 seconds. And this has some quite nice animation on it. So you can actually see here at this point the container, it's running a primary with 2 replicas. It's running on node 1, and if node 1 fails, the node 2 becomes the primary. We have a new replica. So to make up and have that consistency that we've got 3 replicas, a new replica is created on node 4, and then the container can actually fail over to node 2. And another good feature is what's known as shared file. So the example I gave in the presentation was what you would typically in storage speak would be like a block storage device, a read write once. Those who are familiar with NFS, you can have read write many, where that same volume can be accessed by many different containers. And the way we actually achieve this, we actually implement an NFS layer in user space. So as you configure that persistent volume claim that we saw, you can specify it as read write many, and StorageOS will run an NFS server and it will provide that. And then you can, you have the beauty of one container can write to it, and those changes can actually be seen on others, which is really cool, especially cool for, shared things like user file systems, etc. So that was it. And I hope with what I've actually shown here, you see the message I was putting across with. We covered, a very simple use case of this is how you solve persistent storage and make it actually work as it is. But as well as solving that problem, you can then see all of the other benefits that you actually get with this. And hopefully the layout with the examples was useful as well. So I made reference to some bits and bobs. The performance benchmarking cloud native storage solution that I spoke about, that's accessible at that URL. We've got the architecture overview, so bottom left, go and have a look at that. Documentation, it's super easy to get started with, and anyone can actually go and get this forever free StorageOS Developer Edition with up to 5 terabytes of storage. So if you've got your own Kubernetes cluster, you can set this up. You can try those examples, which I'll be sharing. You can try those yourself. And as I said, by all means, please take some of those other ones and try them out. And lastly, on the bottom right, we have our Slack here. Come and speak to us. Pretty much, the great thing with StorageOS, we're all on there, and there's a whole plethora of experience. If you want to talk about storage or anything on the back end, we've got specialized teams who deal with Kubernetes integration with, the control plane. So there's, C++ and the data plane. We've got it all going on, Golang, various different things, and we're a super friendly bunch. So come in, chat to us about this or any other kind of thoughts that you have around storage. And what I'm going to do is I'm just going to bring up, because I added the examples that I've actually gone through here. So I committed them to GitHub. So that's my surname, that's my GitHub username, and you can actually see this StorageOS Redis demo, and all of the ones that I've actually gone through are here. And if anyone's wondering, some of these I've actually reused previous ones. So these are just symbolic links to previous ones.
James, I actually had a question. You referenced the businesses that you worked with earlier, some pretty big businesses that we all know, no doubt. What's the plan for StorageOS this year in 2021?
Oh, very good question. So yes, the plan. So the plan, of course, is to move this forward. And recently, and I've got, this was kindly sent to me. We recently had our 10 million of funding. And there has been a lot of focus there on expanding StorageOS, and this is expanding it in many different ways. We've had a lot of people coming on as developers, as product reliability engineers, also on the sales side as well, and we're expanding that out. And there's a lot of leads coming in that we're working with and moving this forward. So yeah, I think the best thing I can say on that, Joe, is obviously trying to get this out as much as possible. And obviously myself, as you saw on the opener, I've been involved with StorageOS for a long time. I was one of the original advisory board members, and I recently moved away from my career in finance so that I could specifically focus on this with a viewpoint of doing what I've done today. This is the first, the first independent one I've done, but trying to actually get that message out, because I think, persistent storage in Kubernetes, it is confusing, and it's confusing for the reasons I actually showed. You get stuff with Kubernetes, and and I think sometimes until you actually see the downfalls with this, it's hard to appreciate what a platform like StorageOS provides. But then when you see it, it's kind of like a light bulb moment. Yes, now I can do this application and this application. So yeah, hopefully some more of this, and hopefully by the time we come round to do a next one, we'll have to have this honey zoomed out a lot more to fit all of the different ones on.
Yeah, you'll have a 20 million funding card, not a 10 million next time.
I shared that link earlier. please, by all means, connect with me and try out, grab that 5 terabyte license, try it out for yourself. And I mean, if you need any help with this, come to me direct, come to the Slack channel. Always very, very happy to help.